what a perfect square is. So because of Pythagorean theorem, you probably learned about squares a lot. So let's just fill in our chart here, and it's also on my wall, but what are the perfect squares? So 1 squared is 1, 2 squared is 4, 3 squared is 9. We've seen those a lot with quadratics, right? But we haven't really worked on the higher squares. So 4 squared is 16. What's 5 squared? 25. 6 squared is, yep, 7 squared, 49. If you don't know these you need to memorize up to 100. 8 squared, 64. 9 squared is 81. 100. So maybe you don't know these, but 11 squared, yep, is 121. 169. I think the next one's 196 because you just reverse the, is that right? 14 squared, 196. I just remember that because you reverse them. 225. Beyond that, I just skipped to 400. You actually know 16 squared? Oh, yeah. Would you have known 17 squared? Yeah, 16 through 19, I probably won't throw those at you just because I want you to identify when you have a perfect square. So I'll probably use like maybe 1 through 12. It'd be nice to know 13, 14, and 15, but not without a calculator. But definitely up through 100, you should know those perfect squares by heart. Because I feel like I don't have them all memorized. Do you have them memorized, Finn? Do you know 19 squared without looking at my chart? So I felt like if I don't have them memorized, why would I have to have you have them memorized? Okay, so here's what a difference of squares is. We're dealing with quadratics, right? So the degree must be 2. It has to be a quadratic. There has to be 2 terms, a binomial, and A and C both have to be perfect squares. Notice there's no B term, right? AX squared plus BX plus C. What's wrong with you? Okay. I didn't know what you were debating over there. Okay. So the steps are, okay, you're going to take the square root of the first term, take the square root of the last term, and basically one becomes addition and one becomes subtraction. So what you do, here are my couple examples. So x squared minus 9, you make 2 sets of parentheses, because we're going to end up with 2 binomials, and you take the square root of x squared. So that's just x, right? X times x is x squared. So x is your first term. What's the square root of 9? 3. So 3 times 3 is 9, and you make one of them positive 3 and one of them minus 3. That's the pattern for difference of squares. So if you FOIL it back out, see how x times x is x squared? What happens when you do your outer plus your inner? You have negative 3x and you have positive 3x, which adds up to 0x in your original problem. And then 3 times negative 3 is negative 9. So how would you factor part B? So take the square root of 81x squared. What would you get? 9x times 9x. And then you're going to take the square root of 25. So 5 and 5. 1 is a plus and 1's a minus. It doesn't matter where you put the plus. So you could put the minus first or you could put the plus first. See how 9 times 9 is your 81x squared. Outer plus inner are opposites. And then 5 times negative 5 is negative 25. So I just said factor each of the following. If they are not factorable, write prime. So if they're not factorable, either one of these things up here is not being followed. 2 terms, perfect squares. It has to be a subtraction sign. So take a look at 1 through 6, maybe on your own for a minute first, and then we'll go through the answers to 1 through 6 together and the solutions. So if you look at, your answers, make sure that you put 1 as plus, 1 as minus, or else it's wrong. x plus 7, x minus 7, because if you put two pluses or you put two minuses, you end up with a middle term of either 14x or negative 14x. We want it to be negative 7x and positive 7x, so it adds up to 0x. Yes. The vertex of what? Question 1. So x squared minus 49 is just a quadratic in vertex form that's been shifted down 49 units. So it's going to, yeah, the vertex would have been way down here. And then when you go up 1 over 1, up 2, over 2, up 4, over 3, up 9, see how when you go over 7, you go up 49 and you hit the x-axis? So 7 and negative 7 are the x-intercepts. This is intercept form. Remember intercept form? So this is standard form or vertex form, and this is intercept form. So you're getting the x-intercepts. Oh, I don't know what this is. Yes. And the two x-intercepts would have been negative 7 and positive 7. So if we were going to finish this strategy, you're just taking it one step further with the equal sign, that now after you do x plus 8, x minus 8 equals 0, you have to say what x is. X could be negative 8 or positive 8 as your x-intercepts. So making sure that you get full credit when it asks you to solve as opposed to just factor. We're just trying to find out where it intersects the x-axis using a bunch of different strategies. So this would be 2x plus 5, 2x minus 5. And then you're going to use the zero product property to solve for x like we did up top. So take one more minute to finish number 8 and change them. So negative 2.5 or 2.5, right? Okay.